Now, how can we show that this point is collinear? Right? How can we show that this point is collinear? Sorry, let me bring the -2 over here. Yes, now we have how can we show that this point is collinear? Right, so now let's solve for PQ. Right, and I'll be explaining why we are actually solving for PQ. Right, so PQ is equal to OQ minus OP. Now OQ minus OP, right, which is PQ, is equal to, let's say, -4 minus 2. This gives us -6. -2, remember this is -2 minus 0. This of course again gives us -2. 6, right, plus 2, right, because this gives us a positive sign, because 6 minus -2, and this of course gives us a positive sign, and this gives us 8, right. 8 is the expression. Again, let's find rs, the vector rs is equal to os minus or, right. Now os, this is os minus or. Now this gives us 3, right. Os minus or, 3 comma 3 minus 5 gives us 1, and also 4 minus sorry, this should be -4. A slight typo over there, apologies for this mistake. This is -4, right. So -4 minus 0 gives us again -4, -4. Now what can we notice from these two values we've obtained, right? From these two values we've obtained, now we can clearly see from these two that PQ, the vector PQ and RS have a common ratio, right? Means that they can be divided in a certain ratio lambda, right? And it can be seen clearly that PQ is equal to -2 RS. Do you get it? Now let PQ, R and S be position vectors of PQ, RS respectively, right? So what I'm trying to say is that let's, instead of writing OQ minus OP being equal to -2 OS minus OR, we are representing this OQ by the vector Q, and same for OP, and similarly for RS also, right? I think my synonyms are far today. Okay, now simplifying this, we have Q minus P, it being equal to -2S plus 2R, right? Now grouping like terms, right, taking this expression to this side, right, we obtained, or let's just write it, squeeze it down here for the sake of space, plus 2s minus 2r, and this is equal to 0, right. We've moved this equation to the left hand side. Now per the theorem, remember there is 1 in front of the of RQ, right? There is 1 over here, don't forget. There's also 1 over here. We have 2 over here and -2 over here being our scalars. And for points to be coplanar, or for points to be collinear, they have a common principle, and that is the sum of their scalars should be equal to 0. And this indicates that our points are collinear, right? So now we can conclude and say Since the sum of the scalars is equal to 0, PQRS are coplanar, right? Thanks for watching. Please subscribe. This is Teach Me Maths. Love you all.